white pen on a white canvas. That wouldn't work. Okay, so they're saying there's two vectors u and v. That's their names. Lovely, lovely names for vectors. U goes from point P1 to P2. So let's plot P1. 2 on the x, -3 on the y. There's our dot. And then 5 on the x, 1, 2, 3, 4, 5, and 1 on the y, put a dot. That's our ending point. So this is P1, P2. So here's what the vector should look like if you're drawing the vector. Started down there in the bottom left and ended up here. So there's my arrow showing the direction, because vectors have direction, and vectors also show magnitude. The length of that line would be the magnitude. Okay, that'd be the distance we travel to go from P1 to P2. Okay, so we're supposed to, vector u is supposed to be that vector that I just drew. Okay, so to figure that out, what you want to say for u is that it's the change in x. So I started on 2 and I ended up on 5, so I went 3 units to the right, so that's a +3. And then the y component, that's the change in y. I started at -3, I ended at 1, so I rose 4 units on the y-axis. So there's vector u. Okay, that's all we got to do. For vector v, it's the same thing except different point. So we've got different points, plural, sorry. 6, -1, there's a dot right there. And then 9, 3, there's a dot right there. So our vector starts on P3 and ends on P4 because it says terminal points P4. So to find vector v, I want to use my x component to be the change in x. So I started at 6, I ended up at 9. I went 3 units to the right, and going to the right is positive. I started at -1, I went up to 3, so I went 4 units up, so that's positive. Okay, so the question was, are these two vectors equal? Yes, they are. They have different origins, but we say they're equivalent vectors because they share both the same direction and the same magnitude. If you were to, they both have the same x and y components. Okay, so they're definitely the same vector. That's it. That's all I wanted us to do. If they had different numbers, they wouldn't be the same vector.